All right, welcome back, everyone. Let's take a look at another example of random variables. So here the example reads, a random sample of 900 adults was surveyed, and they were asked, what is the ideal number of children to have in a family? The results of a random sample of 900 adults are shown below. So notice we know the total number is 900, and the results are here. So in other words, the number of children, somebody said 0, that was 10 individuals. Number of individuals who said 1, that was observed 30 times, so that's the frequency. And we can see that the highest number that somebody responded with was an interesting number of 6. Notice that they said ideal, not how many you want, but what's the ideal number of children, whatever that means. All right, let's go ahead and start. This is like an example that we could have seen on day number 1. But now we're going to go ahead and address this problem with proper notation and vocabulary of the section. So the first question that they ask is define a random variable in this experiment. So what is our random variable for this experiment? Remember that that simply means what is it that you're interested in? So it's a variable of interest, and it's random because you don't know what it is until you ask someone. After some thought, I hope that you all agree that it's that question, what is the ideal number of children? It's the number that somebody would respond with. So here we're going to go ahead and write capital X, because that's my random variable, is going to be used to denote, so anytime you see capital X, it's going to represent the ideal number of children to have in a family. So in other words, I'm interested in understanding this variable. What is the ideal number of children to have in a family? B, find the probability distribution of the random variable X as a table. So let's go ahead and remember what that means. That means you have to include every possible outcome, which kind of easy because we have a little table right here. So we already know that this is the ideal number of children could be this small value. The small value in this case is 0, could be 1, could be 2, all the way up to 6. And the last thing I need to do is I need to go ahead and find the probability, the corresponding probability. So what is the probability that the random variable takes on this specific value? Here it's a little simple because we saw this in chapter 5, right, in the probability section, that if you have a table like this, so this is the empirical probability approach, we have a random sample of 900. And to find the corresponding probability, I simply need to go ahead and divide. So that's the relative frequency. I go ahead and take 10 divided by 900. Throw that into a calculator and we get 0.011. So go ahead and find the corresponding probability for all of these. I'll go ahead and pause the video, or you go ahead and pause the video, and go ahead and fill in the rest of this table. Okay, so I went ahead and found the probability for all of them. So that solves part B. I listed out all possible outcomes. Really, they listed it out for me. I simply had to go ahead and find the probability. So let's go ahead and just verify. So for part C, we say verify that your answer to part B satisfies the 2 requirements. Remember that the 2 requirements are number 1, that 0 is less than or equal to the probability that your random variable is any specific value, and that's less than or equal to 1. So notice we just have a valid probability. Condition 2 is that the sum of all of the probabilities is 1. So for condition number 1, you just use your eyes. You go through all of these and you're like, are all these between 0 and 1? In other words, you don't want anything over 1 and you don't want anything negative. And the answer to that is yes, we meet condition number 1. So we're just using our eyes. Condition 2 is the sum of all probabilities is at approximately 1. So you have to actually do this. You have to, in other words, just go add a 0.011 plus 0.333 plus 0.5778. and continue until you get to 0.0033. Go ahead and do that. Pause the video and tell me what you get. It turns out that the sum of the probabilities for this example is 0.9999. It's not actually 1. That has to do because I didn't keep all of the decimals. So in reality, this second condition is that when you add all of the probabilities, you want to get a value very, very close to 1 because of rounding error. And we did actually get that. We got 0.9999. So that is good enough. All right, let's wrap up. Find the probability that a randomly selected participant will respond with 1 child. And here is where the random variable, hopefully you see is useful. We're going to write the one probability, randomly selected participant will respond with 1 child. Notice that that's the random variable x. So I'm going to say here they're asking what is the probability that my random variable is 1? And it's very easy. I simply go ahead and look at my table. Here is the probability that my random variable, oh no, that's wrong. That's not the correct probability, sorry. I want 1, which is right here. So it's going to be 0.33. Ooh, I actually forgot a 0, so there should be a 0 in here. 0.033. Now there's a follow-up question. Would this be unusual? And what we want to remember is that we've agreed that unusual means that it's unlikely to occur. So that means that the probability is less than 0.05. In other words, 5%. And the probability here is 0.03. 0.03 is less than 0.05. Because of that, this is unusual. In other words, I don't expect somebody to respond with 1 according to this distribution. Part E, find the probability that a participant will respond with at least 4 children. So again, I'm going to utilize the random variable. So when they say at least, that means that they want to hear 4 or higher. So here, this will be the probability that X is greater than or equal to 4. So that means that we could observe this one, or this one, or this one. And that's kind of nice because here I'm actually going to use the addition rule. And that means that it'll be equal to the probability, because I have disjoint events, that my random variable is 4, plus the probability that the random variable is 5, plus the probability that my random variable is 6. In other words, I simply go ahead and add the corresponding probabilities. Yeah, I hope you get the point. Let's just highlight this. So I'm simply adding these probabilities right here. And I get 0.1. All right, we have one final question, which is sketch the distribution as a graph. So for this one, we actually do need StatCrunch. So let's go on over to StatCrunch. And what you're going to do, and by the way, the commands are posted here. One of the first things that you want to do is you want to type in your distribution. So that means at the very top, we're going to go ahead and call that X. And at the next part, we're going to go ahead and Call that P of X. All right, and through the magic of editing, I've already input the table. So you can see that we have X on the left-hand side and the probability on the right-hand side. And what we're going to do is we're going to go to the command stat calculators, and then select custom. Struggling here. Let me see. All right, so here it is, stat, summary, calculator, sorry, and then custom all the way at the bottom. Once you do that, you'll get this dialog box. And all you got to do is you got to tell it, what are the values of your random variable? It's easy for us because we called it X. So let's select that. And then it says, where are the weights? And these are basically the probabilities. So then you press P of X, press compute, and you are done. So if you look at this carefully, you can see that it's got the possible values. So little x on the x-axis, and we see 0, 1, all the way up to 6. The height of the random variable, the f of x, is the probability. And we can see that this makes it a little bit easier to see that the most likely outcome is a value of 2. So the most common response to what is the ideal number of children is 2, and it's very unlikely that people will say 6 or 0. So the graph is very, very useful. All right, I want to show you one last thing, and that's this little part here at the bottom. This is the reason why it's called calculator. What we can do is we can change this and find what is the probability that a random variable will take on a specific value. Like, for example, I'm not sure if you remember D. D was the probability that the value of X is 1. We could have simply changed this symbol here to equals 1. Press compute. And notice how they've highlighted the bar at 1. So they're essentially just considering that one, and it's 0.033. We also went ahead and found the probability that X is greater than or equal to 4. We found it by hand earlier, and we got 0.1. Notice how StatCrunch is highlighting in red 4, 5, and 6, because that is what it is adding up. And so this is the reason why it's called a calculator. We're going to go ahead and use this tool a lot. So please make sure that you review this example and let me know if you have any questions.